Welcome to Learning to Engineer. Today we will solve some problems in the concept of diode. Is 3 greater than 5 or 5 greater than 3? If you are able to answer this question, you will be able to solve the problems involving diode circuits very easily. It's that simple. Let's get started. First, we will solve simple problems in series and parallel circuits of diodes. Then we will solve a little tricky problem. If you want to know the basic concepts of diode, how it operates and how it behaves in forward bias, in reverse bias, the characteristics, diode current, Shockley's equation and all, you can click this video and watch that and jump back here. Okay. Determine V0 and ID for the below circuit. We have a series circuit involving a silicon diode and a red LED. The drop across the silicon diode is 0.7 volt and the drop across the red LED is 1.8 volt. It is a simple series circuit. Since the applied potential 12 volt is greater than the forward bias voltage of silicon diode, this diode is going to be on, and same is the case for red LED. Okay, but the forward bias voltage of LEDs is slightly around 2 volt. For red LED it is 1.8, for green it is 1.6, and it depends based on the color that the LED emits. Okay, so we will solve this problem. First we will find out the V0, then we will find out the diode current using the Kirchhoff's voltage law. Since both these diodes will be on, we can replace that as a series circuit like this. You have a 12 volt battery in series with silicon, which has a drop of 0.7 volt across these two terminals, and the drop across the red LED is 1.8 volt. Then we have this load resistor that is in series, 680 ohm. Okay, so what is the voltage across 680 ohm? This is V0. V0 is equal to 12 minus 0.7 minus 1.8. This is equal to 12 minus 0.7 minus 1.8. 9.5 volt. Next we will find out the diode current. The diode current is the current that's passing through this diode. This is the diode and this is the red LED, right? So since all of these components are in series, the current doesn't divide. ID is the same current that's flowing into the resistor as well as the diodes. ID is equal to 9.5 volt, which is the voltage across these two terminals, divided by this resistance, 680. So this will be 0.0139 ampere, which is approximately same as 14 milliampere. Okay, this is a very simple problem which involves the basic concept of diode operation. So once you are able to understand the forward bias and reverse bias behavior of a diode, you will be able to solve this problem on your own. Next, I am going to solve another problem involving two diodes in parallel. It is the same concept. So I would recommend you all to pause the video, try it on your own, and then continue watching the solution. Okay. What is the value of R to ensure the current through the green diode to be 20 milliampere? The reverse breakdown voltage is given as 3 volt and the average turn-on voltage of the diodes is 2 volt. We have two diodes in parallel. One is the green LED, next is the red LED. If the green LED has to be on, the potential at this end should be greater than the potential at this end. Okay, so we have to design the value of R in such a manner that it doesn't take away so much of the voltage and it has a little amount of voltage at this end to be able to turn on the green LED. Okay, and if you understand this a little bit, if the current direction is from here to here, which is in the downward direction, green LED will be on, and if the current direction is like this, when will it be like this? This is 0 volt, and if this is at a negative potential, then the potential at the P side of the red LED will be more than the N side. But in green LED, the potential here, which is 0 volt, will be lesser than the potential at the P side. So green LED will not be on when this is a negative potential. Okay, so this potential has to be positive, which is above 0. So we have to design the value of R in such a manner. Okay, so it is given that the average turn on voltage of both these diodes is 2 volts. So it means that this potential should be greater than 2 volt. Okay, so this also implies that the drop across the green LED is 2 volt. And what is the current through this resistor? It ensured that the current through the green LED should be 20 milliampere. When this is greater than 2 volt, red LED will be off and green LED will be on. Thus, we can replace this as an open circuit. Okay, because the red LED is going to be off. When the red LED is off, it becomes a series circuit involving R and a green LED. So when you establish this configuration, green LED will be on, you will get green light and no red light, because this will be under reverse biased and this is open circuited. Okay, so what's the current that's to be ensured? We have to ensure that 20 milliampere flows across this R resistor. So what is the voltage difference? 8 volt minus 2 volt divided by R. Okay, because what is this current? Difference in the potential across these two ends divided by this resistance. So from this we can get the value of R as 6 divided by 20 milliampere, which is 300 ohm. When we are connecting 300 ohm resistor here, then it will ensure the operation smoothly. Okay, so now we will solve another problem which has two diodes in two separate parallel paths. Okay, we will solve that now. Assuming the diodes to be ideal in the figure for the output to be clipped, the input voltage Vi must be outside the range dash. Be careful, they are asking what should be the input so that the output has to be clipped. Okay, they are not asking the output voltage, they are asking the value of input voltage for which the output will be clipped. We will solve this problem. Yeah, of course, 4 options are given to you to choose from. Okay, so before that we will first understand the circuit. We have a AC source. Let us assume this to be sinusoidal source. I think it's given that it's yeah, it implies that this is a sinusoidal source, right? So we have a 10 kilo ohm resistance in series with 10 kilo ohm load in case both of them are open circuited. When will that happen? When both of them are in reverse bias, meaning that when the P side potential should be less than minus 1 volt. Okay, so let me denote this voltage to be VA. This is also VA, this is also VA, and this is also VA, because all three are in parallel paths. Okay, so when VA is less than minus 1 volt, what will happen? D1 will be off. Okay, what will happen to D2? We will see that. When VA is greater than minus 2, then what will happen? When VA is greater than minus 2, the N side voltage will be greater than the P side voltage. Therefore, D2 will be off. Okay, so when it is just less than minus 1 and it is greater than minus 2. So in between, when VA is between minus 1 and minus 2. So VA is greater than minus 2 and less than minus 1. Both these diodes will be off. So when both these diodes are off, what will happen? You will have a series sinusoid Vi, which is in series with a 10 kilo ohm. Diode D1 is off, D2 is also off. So I am replacing both of them by open circuits. Then you have a 10 kilo ohm. So now this 10 kilo ohm is in series with this. Okay, so voltage divides. What is the value of V0? V0 is the voltage across 10 kilo ohm, right? So V0 will be Vi divided by 2. Okay, this is also equal to Va. So what? Let's substitute here and see what should be the value of V0. Okay, Vi by 2 minus 1, because we have found out the value of V0 for which the diodes are off. We are asked to find out the value of Vi for which the diodes will be clipped off. See, for the output to be clipped, the input voltage must be outside the range of what? Okay, that is the question. What is the value of Vi? So this implies that it should be minus 4 to minus 2. Okay, this is option B. This is option B. Okay, so if you think a little bit, you can understand that it is only during this range that both these diodes will be clipped, and only then it will not disturb with the V0. Let's say, for example, VA is greater than 1 volt. What will happen when VA is greater than 1 volt? D1 will be on. So I can replace D1 as a short circuit when VA greater than minus 1. So it is minus 1, 0, 1, 2, 3 for all these voltages. D1 will be short circuited because it's functioning, and D2 will be open circuited. Okay. So what is V0? So V0 will be minus 1 volt. Because of this short, there is only a battery connected between these two ends, and the potential across this will be the potential across 10 kilo ohm, because both these branches are in parallel. VA is minus 1 volt. Same way, here the potential is minus 2, and if VA is less than minus 2, when VA is less than minus 2, which is minus 3, minus 4, minus 5, minus 6, so on, what will happen? We are making this forward bias, will be short circuited, and D1 will be off. So at this instant, what happens? Minus 2 volt appears across this 10 kilo ohm, because this branch is in parallel with this branch, and this is open circuited, so the current will come here, it will divide here, and the voltage across this is the same as the voltage across this 10 kilo ohm. So this will be minus 2 volt. So either way, there will be one diode which is operating, and ensure that there is no clipping that's happening in the V0. When both these diodes are off, you will be able to get the share of Vi on the load. So this happens in which range? In this range. Okay. So thanks for watching. If you have any doubts, or if you want any other problem which I have to teach in this topic, or maybe any other topic, you can email to learningtoengineer@gmail.com. Thank you.